I did not. I kind of forget sometimes. Yeah, it's right here. All right, this is where we ended. Yes, did you write that down? And so the idea of a differential, and if you look at the problems, if you've got to those problems on your homework, is they give you a value for dx, like a decimal, and basically it's like a little change, and again, it's using as approximation for how much is y changing given a change in x. And there's really two different types of problems that they're going to give you. One type is they're going to actually give you a value for dx that you plug in and get a decimal, and the other type of problem is just practicing writing differential equations. So here's the one where you actually approximate. It says find the differential dy and evaluate dy for the given values of x and dx. And when we do these, especially when we have the test over this chapter, I hope that this part is the easiest part of the whole test, because you just have to remember what a differential is, and you take the derivative and you plug the values in, and that's it. Like, that's the whole problem. So it's probably like the least amount of thinking of all the stuff that we're going to do this whole chapter. And so I just picked a little polynomial function here. They give you the value for x, and they give you the value for dx, or the change in x. So you have to remember that dy is equal to f prime of x dx. That's the one thing you have to remember. And if you remember that, you're just trying to tell me what dy is. Like, you're trying to give me a value. So can you find the derivative of y? It would be 5x to the 4th plus 37 times dx. And technically, we should probably put parentheses around that to remind ourselves that that dx is times the whole thing, not just times the 3x. Right, Caitlin? Well, I'm going to get there. I just haven't got there yet, right? I don't know. I just forgot myself. Oh my gosh, what's wrong with me? I don't know either. Do you know I almost didn't come to school today because I couldn't find my keys? Oh my gosh! I almost didn't come to school today because I couldn't find my keys. Like, I said, Parker, I can't find my keys. I can't drive to school. And I'm like freaking out, and I call my husband, who's already left for work, and I said, is there any way you've seen my keys? Because I have no clue where they are. He's like, they're on the shelf by the back door. I saw them last night at 10:30 and thought, you're never going to find those in the morning.
Thanks for telling me, honey.
And I was like, you could have taken it and put it in my purse. But anyway, thank you, because now I can go to work. But I was a bit stressed. I'm losing my mind.
It'd be like 7 times the right time. You're like Patrick 3 times.
I know.
What is 3 times 4?
I was just getting so excited about the parentheses, because if you weren't actually going to work this out, this is the other type of problem. When it just says find the differential, this is the answer. If you don't put parentheses around this, it looks like it's just 37 dx and not parentheses. So I just wanted to point out that it is times the whole thing, and in that whole getting excited about parentheses, I forgot 7 and I put an x in there. I don't know.
You forgot 7?
But now, since they give us values, we're just plugging in, right? We're just going to get a number answer. We're just going to plug in 1 for x, and I'll show my work here.
Oh my goodness.
5 times 1 to the 4th, I'm really okay, plus 37, and then they tell us dx, and dx is usually a really small number because it's a small little change in x. And you can just use your calculator from there, and you're just going to get a decimal answer.
Do we do 5 plus 37 first?
Yeah, you can do it all at once if you want. But yes, like if I was going to write this out, 5 times 1 to the 4th is just 5, plus 37 is 42 times 0.01. What which I think is just 0.42, right? It's just like this small little change that kind of represents, like, if they tell you how much X is changing by, then you can find how much Y is changing by. I don't know. We don't really do a whole lot with it. I'm not really good at explaining this, but let's read the book and see what they say. What Leibniz said. If I didn't do these notes for you and you went back and read the book, you would find out way more about it than what I tell you in class, because I don't really care that much.
I would know the bare minimum. I don't know how many people have read the book. I go back and get crazy.
I'll keep looking while we do the next one. So you do this one while I try to figure out what we're actually doing.
Cool, Trey.
It's your favorite. Come on, you can take the derivative of sine, and you can plug sine in for that.
I feel like calculus is a fairly.
I need to find the comic about calculus because it's really funny. It's like this big giant mountain, and like with little steps along the way, and it's very depressing.
Like, you know, whenever you start over, you're like, okay, I can see the top here, and then you keep going, and it's like the hill is like going down as you're going up, and you just keep going. You think it's gonna get easier, but it's like one of those obstacles where like you think you're walking up, but you're really walking down, just looking up. Oh my gosh, I don't remember how to do this. Cosine.
Sarah.
It's a chain rule.
Sarah, I'm trying to say.
Yeah, do you have to do chain rule?
Chain rule. Derivative of, like, outside function, which is sine, times the derivative of the inside function, which is...
Do I have to pull the 3 out? You can't pull the 3 out in the middle. It's
Chain
stuck.
rule or product? Chain rule, right? You cannot separate this, right, Caitlin? You cannot just write sine with nothing next to it. This is like sine of 3x. So, like, u is your 3x. So this is the inside function. This is the outside function. So you take the derivative of the outside function, leave the inside alone, times the derivative of the inside function.
That's almost like the third one.
Okay, here's the whole thing. If you know that dx is changing, that's like how much you're moving on the x-axis, right? So if you know that, then you can take that point, pi plus, like, use pi and how much the x is changing to find the dy, which is how much the y is changing.
People really use this?
I don't know.
I do.
Here's an example that you could use it in. The radius r of a circle increases from 10 meters to 10.1 meters. You can use the differential to figure out how much the area is changing by just looking at how much that's changing.
So you don't have to take the whole area.
So you don't have to do the whole thing. You can just use this. Is it used sometimes? Yes. Are you going to take probably a class in college called differential equations? You probably are. So you'll use it in college. But most people in their everyday life, you're right, they're not going to do it.
Well, I didn't know like a job would do this.
A calculator probably, a computer probably does it for us.
What's 3 times 2, 1, 2, 2, 1, 2, 6, bring it there, is it? Look at that. I want to listen to these notes because I yelled at Sarah. I'm pretty sure my embarrassment was you.
I did my math wrong.
It's very
Again, remember that this is the chain rule. So this really would be the derivative of sine of 3x would be cosine of 3x times the derivative of the inside function, which I'm going to put my 3 in the front, times dx. And then we're just going to plug that in. So we get 3 times cosine of 3 pi times negative 0.02. Cosine of 3 pi is negative 1. So that's negative 3 times negative 0.02, which I believe is positive 0.06. So we can say when the x is changing by negative 0.02, then that y value or whatever the real life application would be changing by 0.06 without having to do a whole big problem. So that's what that used. We're not really going to do that. We're just kind of touching the surface with it, and then next semester we'll solve. Remember those lovely like half-life problems with the growth and decay?
Yeah, I like those.
we'll solve some differential equations, setting up problems like that, and probably there's a good chance that'll be on the AP test, but we can't do that yet. So this is it. I know they fall in the water a lot when I wash my hands,
I feel like you could,
or in my food.
like, whenever I wear shorts like that, my ferrets would crawl my fingers to sleep. Your ferrets? Your ferrets?
You have too many animals.
I did, but they died. One died the other died because it was wrong. Did that really happen? Yeah. So tragic.
And we just laugh.
The first one was Chewy, and he had a thyroid gland problem, and he lost all his hair and died. And then Lettuce died because she was sick.
Lettuce. Maybe she died because her name was so terrible.
I didn't think it was Lindsay's ferret. What's the ferret?
All right, this is the other type of problem. If they don't tell you what x and what dx are, then you just write it as dy equals f prime of x dx, and you just leave it with the dx in the problem. Just kind of, again, some practice with differentials. Notice the difference in this, they just put a d in front of it, but that means take the derivative of this, basically.
Is the D an actual problem?
No,
It's just there.
it's just there because that's how they write to do differentials. Just some notation. Well, we could do a biology problem.
Oh, thank you. I can't even do the first
John Loiseau discovered the formula to predict how much the radius of a partially clogged artery has to be expanded to restore normal flow. And then we could.
That's anatomy, no biology.
Anatomy is a subset of biology.
Do you guys think that very far into the like, it's like, it's just not actually. He's way normal. Yeah.
So my derivative, again, this is a chain rule problem. So that's 1/2 times 1 minus x squared to the negative 1/2. Don't forget the derivative of the inside would be negative 2x. And then we just attach that dx. That's really the only difference with normal derivatives and differentials, is it's not dy over dx equals. Put that dx over here. And then obviously I want you to simplify this, right?
Wait, this one.
Oh my gosh, Sarah, can you let me get through this before we talk about that? So I think I'm going to write this as negative x over the square root of 1 minus x squared dx. And since this is just a fraction, I don't have to put parentheses around it. It's not wrong if you do. But if this was addition or subtraction, you would need parentheses there next to your dx. Otherwise, it would not be mathematically correct.
Why is it squared?
Because it's squared here, and when I take the derivative of the inside, I don't change, or the outside, I don't change the inside, right?
So we can't do anything.
Can't do anything else because we don't know what dx is. It's just, that's a differential equation. I like those two. That's it. That's what we missed today. I don't know. I've always gotten through them before.